Don't realize this, but this is my second recording of this video because my first one got interrupted by an announcement. I hope this one doesn't. I'll just keep talking through it if it does this time because I've gotten a long way. But this is the second bonus problem, and this is a bird's eye view of the situation that's happening here. So if you look at it, you've got the smaller triangle, or this big triangle, I guess. You've got a train that's going at 25 feet per second, and it crosses the path, and then 5 seconds later you have a car that's crossing in this direction, and it's traveling at 140 feet per second. And it asks, at what rate are the two vehicles moving apart from each other 3 seconds after the car passes by? Well, 3 seconds after the car passes by, the train will have passed by this intersection 8 seconds earlier, so it will have gone 200 feet during this amount of time. 3 seconds after the car passes, it will have gone 120 feet. So here's our path, and from this, we've got this x right here. Now, x is actually not the distance that the train is from the car. X is the distance the car is from the train, but not the train, but just below the train. And I'm going to call this side X here. Well, now we have a second triangle that's happening. Remember, this train track is 20 feet in elevation, running parallel to the ground, fortunately. Makes the problem easier. So we've got this side X here, which again represents the distance from the car to just below the train. The tracks are 20 feet elevated. So this is the distance, and I called it TC, train car, for lack of a better name. That's going to be, this is the side that we're interested in. This is the rate of change we want right here. We've just got to get several steps in to get it done. Well, let's start. We have, first off, figure out this side here. It's not a right triangle, so the Pythagorean theorem will not go into effect. So we have to use the law of cosines to come up with this side. So it's x is equal to the square root. And I'm going to be calling this side A and this side B. So it's A squared plus B squared minus 2AB times the cosine of the angle. Cosine of 30, square root of 3 over 2. These cancel out. Let me do the rest of the arithmetic in my head. All right, I come up with 113. So you carry the 2 and 5 and 7 and carry the 6, and I get 730537. 357, sorry, got that mixed up. So this is my length of x. And I'm just going to write 113 here because I'm going to run out of room. So now this is this side right here. So now I need the Pythagorean theorem to find out the distance of side TC. Again, doing the Pythagorean theorem here, I come up with 115.02 51304. So that becomes that distance right there. Now I've got to start, that's at this instant. Now I've got to start throwing in the rates of change into play. Well, to figure out the rate of change of this side here, I'm going to, again, need the law of cosines here. And I'm going to write it out entirely. It's x squared equals a squared plus b squared minus 2ab times the cosine of c. Now, I'm not going to write out the cosine of c. All of these values are changing throughout, but the one thing that's not changing is this angle. This angle is going to stay 30 degrees the entire time. So I don't have to call it the trig function. I can put the physical value of it, which is the square root of 3 over 2. Now, those things cancel out. Now I've got an easier, if I had this as a trig function, doing the derivative of this would be a product rule within a product rule, so I'm glad I was able to put a constant in there. So I get 2x dx dt equals 2a dA dt plus 2b dB dt minus the square root of 3 times a times b. And at this point right here, it's 2 times, all right, my x is this, and I'm going to write 113. When I plug it into my calculator, I'm not going to put 113 in there. All right, dx dt is what I'm looking for here, equals 2a, a being 120, and dA dt being 40, plus 2b, b is 200, and dB dt is 25. Now, the derivative of this, I did this wrong. This should have been the square root of 3 times a dB dt plus the square root of 3 b dA dt. All right. So from that, I get it's minus the square root of 3 times a, which is, again, 120, and dB dt is 25. All right, distribute the negative in, so minus the square root of 3 times b, which is 200, times dA dt, which is 40. All right, I'm going to do that arithmetic, and I'm going to start a second video for you to finish up the problem because this one is running too long.